Tunaendelea na lecture series yetu, na hii ni lecture 6. Hii ni lecture 6. Hii ni lecture namba 6. Leo ni tarehe 31 Januari 2024, mwaka unasogea. Sasa katika lecture ya 5 iliyopita tuliangalia kuhusu advantages of high transmission voltage, of advantage of using high transmission voltage to transmit electric power. Tuliona kwamba if you use high voltage for transmission of power, inapelekea kwa reduce the volume of conductor material. Kama tuliona kwamba the volume of conductor material is inversely proportional to the square of the line voltage. Na katika analysis yetu tuli consider three phase transmission line, na hii analysis pia iko valid for single phase, for DC transmission lines na kadhalika. Sawa. Na sasa leo tunaangalia point ya pili ambayo ni tuliona kwamba ukitumia high voltage to transmit power, the transmission efficiency will increase. Kutona point ya pili ni kwamba the use of high transmission voltage it increases the transmission efficiency. Transmission efficiency. Okay? Na tunajua kabisa in principle efficiency ni ratio kati ya output power output divided by power input. Sasa kwa context yetu ya transmission line, power output ni power transmitted au power received, okay, divided by power sent. Okay, sasa kwa mfano of the transmission line, suppose this is a generator, hapa umeme. Okay, after generation you step it up, okay, by using transformer, then you transmit using a transmission line up to the load center. Okay, hii ni generation. So kwa hiyo after generation you have to send this power to the load center. Kwa hiyo this side, let's say this is side A, this is side B. This side A tunasema ni sending end, this is the receiving end. Okay, kwa hiyo at the sending end we send power P S, and at the receiving end we receive power, let's say PR. Okay, kwa hiyo the received power ndio power ambayo imefanikiwa kuwa transmitted. Okay, that's why kwa hiyo tunasema kwamba the sending end power PS, sending end power au power send sawa sawa na power input. Okay, and the receiving end power PR ni power output, ambapo power imefanikiwa kuwa transmitted from point A to point B. Kwa hiyo kwa context ya efficiency hapa tunaweza kusema efficiency ni sawa sana kusema power out over power input, okay. Lakini tunajua kwamba if power out, this is simply power out, okay, but power input sasa na power output plus losses, ndio. Kwa hiyo power output plus losses ndio formula ya efficiency, au wengine wana modify kwa kusema power output sasa na kusema power input minus losses divided by power input. Hizi ni formula zote za efficiency ambazo inategemewa na data ipi unayo ili uweze kuitumia. Sawa. Kwa hiyo sisi current tuna data, tunajua kwamba kiasi cha power ambacho kimekuwa transmitted. Kwa maana ya kwamba kama load yetu hapa ni let's say ni 100 megawatts. Okay? This is our load here is 100 megawatt. Kwa maana hiyo this transmission line has to transmit 100 megawatt in order to meet the load demand. Kwa hiyo our load demand here is the power transmitted, or simply the power output of that transmission line. Because this transmission line will have some losses, so we have to send more than 100 megawatt in order to be able to transmit this 100 megawatt to meet this load demand. Okay, kwa hiyo Kwa hiyo kufanya manuva hapa, sorry, kwanza tunasema efficiency of transmission line. Let's say efficiency of transmission line equals to, let's use this formula of efficiency. Sasa tunasema power out over power out plus losses. Okay? Ambapo sasa kusema sasa power output is simply P, load demand or transmitted power kama nilivyoelezea hapo awali, over power out P plus losses W. Okay? Tunaona kule W tulidenote kama power loss. Okay? Sasa tunachobaki sasa hapa ni mathematical treatment. Sasa tushapata concept. Kwa hiyo efficiency of transmission line, sasa kusema factor out P from the denominator, tunapata P over P1 plus W over P. Okay? So in simple algebra, ambapo sasa kusema 1 over 1 plus the power loss over P. Okay? Sasa tukiendelea kufanya manipulation zaidi, tutapata efficiency of transmission line. Sasa kusema 1 plus W over P bracket power negative 1. Okay? Okay? Simple algebra. Kwa hiyo tuangalie kitu hapa, let's apply binomial theory of expansion. Nadhani kama tumesoma algebra vizuri utakuwa unakumbuka hii kitu. Uhandisi ni hesabu. Uhandisi ni hesabu. Kwa hiyo kama unakuwa mvivu kwenye hesabu huwezi kuwa mhandisi mzuri. Kwa hiyo kama mhandisi mzuri lazima pia hesabu iwe inapanda kidogo. Kwa hiyo from binomial theory of expansion, tukijikumbusha kidogo, tukiona a plus b power n, kama binomial theory tunasema kama sasa kusema a power, sorry, sasa kusema a, ndio kusema a power n b power 0 over 0 factorial plus n, sorry, plus a n minus 1 over b power 1 over 1 factorial plus n minus 1 a n minus 2 b power 2 over 2 factorial na kuendelea. Okay? Kwa hiyo katika expression yetu hapa, let's say this is equation 1. Okay? Equation number 1 hapo tunaona kwamba our a, what is our a? Our a is 1. Okay? This one. Our b is w over p. Now we apply sasa binomial theorem of expansion over p. So and our n is negative 1. Okay? Kwa to apply sasa binomial theorem of expansion tutapata efficiency of transmission line sawa na 1 plus w over p, tuandike tena to see. So sasa na kusema our a is 1, a power 0, a power n, ni 1 power negative 1. Okay? Plus b power 0. What is b? B ni w over p power 0. The whole is over 0 factorial plus n. What is n? N is negative 1. A what is n? A what is a? A is 1. A what is n? Negative 1 minus 1. Okay? This one over b power 1. B, what is b? B ni w over p power 1. The whole is divided by 1 factorial plus other term tuishie hapa tuchukue the first two terms. Okay? Okay? Kwa hiyo tujaribu kucopy kwenda kwenye page nyingine. Select copy. Ya, imetokea vizuri kabisa. Tunaendelea. Kwa hiyo coefficients of transmission line efficiency of transmission line tulikuwa sasa kusema 1 power negative 1 over times W over P power 0. Any number power 0 is 1. 1 power negative 1 is 1. Okay. This is become power negative 2. The answer is 1 here. Okay. E WP over 1 in WP over 1 hivyo inakuwa negative minus WP W divided by P. Okay. Let's say this is equation number B. Okay. Na pia tunajua kwamba power loss W is given by 3 times I square times resistance. Ambao sasa tunasema 3 times I square, resistance is resistivity low times length over area. Okay. Kwa hiyo tukifanya some maneuver here tutapata sasa kama 3 times current. Let's decompose this current. This current times current times resistivity low over area. So power loss W sasa tunasema this is combine this A and the current, tunapata 3 times current over area times current I times length times rho L. Okay, hapo iko sawa. Tunajua kwamba current over area is equal to current density. Okay, it is current density, the current per unit cross section area. Okay, ambayo inakuwa denoted kama J. Kwa tunaweza tukasema I over A is equal to J. Kwa hiyo W nataka kusema 3 times J. Okay, I resistivity low times length. Okay, lakini pia tunajua I is given by power transmitted over under root 3 times line body times cos I upon load power factor. Kwa hiyo tukisubstitute kwenye this tukisubstitute I, tukisubstitute this P over under root 3 VL cos under katika sehemu ya current I, napata W power loss W equals to 3 times J current density, okay, times P over under root 3 VL both I, which is in the bracket, times resistivity low times length. If you multiply by under root 3, you rationalize the denominator. Under root 3 times under root 3 is 3. This 3 cancel is 3. Okay, so tunapata W equals to under root 3 times J times P over VL cos phi. Okay, then tuko sawa hapa. Kwa hiyo W equals to under root 3 J P, sorry, nisawa hapa kuna resistivity low times length. Okay, resistivity low times length over VL cos phi. Kwa hiyo naweza tukasema divide by P both sides. Okay, divide by P both sides, tutapata W over P equals to under root 3 J resistivity low times length over VL cos phi. Okay, let's say this is question number 3. Okay, kwa hiyo kwa question number 2 tuliona kwamba efficiency of transmission line is given by 1 minus W over P. Tuliona kwamba efficiency of transmission line is given by 1 minus W over P. Ndio tuli drive tukafikia mpaka hapa. Kwa hiyo tunaweza tukasema efficiency of transmission line, so tukisubstitute this is question 3 into equation 2 ambayo ni hii hapa, tutapata 1 minus W over P ni under root 3 J omega resistivity low, sorry, times length over V over VL cos phi. Okay, kwa tunaweza tukasema sasa efficiency of transmission line equals to 1 minus under root 3 times J times resistivity low times length over VL cos phi. Ndio na final equation ambayo tumepata. Sasa ukiangalia hapa for the same conductor size, for the same size of conductor, ndio, for the same size of conductor and same load and the same amount of load au power transmitted, ndio. J is constant. J is constant. Current density is constant. Kwa pia resistivity is constant. Inadepend na length of conductor. Inadepend na nature of conductor material. Na length is constant for the same transmission distance for the same load power factor. Okay? Kwa hizo parameter J, resistivity, length and cos phi is parameter ni constant. Kwa tunaona hapa parameter ambayo ina vary ni transmission line voltage VL. Sawa. Kwa hiyo if you increase VL, okay? If you increase VL, itatokea nini? This is the whole term, hii term yote, okay, will decrease. Okay? If this term decreases, sawa, obviously efficiency ita increase. Kwa sababu utakuwa na minus small amount of number from 1. Itakuwa ni 1 minus decrease the number. Kwa hiyo obviously the term of efficiency will increase. Okay? Kwa hiyo tunasema kwamba increase of transmission line voltage increases the efficiency of transmission. Efficiency of transmission. Increase the efficiency of transmission of electric power. Nadhani kwa lecture hii tutaishia hapa. Katika lecture inayofuata tutaangazia namna gani high transmission voltage ina decrease and the voltage drop katika transmission line. Asante kwa kuendelea kunifuatilia na kusii tu uweze kusubscribe, uweze kushare na like kama video hii umeipenda, ili tuweze kuwa pamoja katika lecture nyingine kuhusu uhandisi wa umeme. Asante.